In this video, let's get into implicit differentiation. Before we get started, let's talk about explicit and implicit functions. So say we have y equals to x minus 3. Wherever you are given your function y written explicitly in terms of x, something like this, we would say we are dealing with explicitly given function or explicit function. In other words, you have your y alone on one side of your equation and everything else on the other side of your equation. Alright, more generally, if we have y equals f of x, so y equals something, so we would say we are dealing with explicit functions. For instance, y equals x cubed, y equals 3x squared minus 4x plus 2, and so on. So in a nutshell, it's standard normal functions that you used to work with. Now, besides that type, there is another type of functions that cannot be solved for y. Say we have x squared plus y squared equals 9, which is known as the equation of the circle with a radius of 3. So this equation cannot be solved for y. We cannot write y explicitly in terms of other terms. So again, this equation contains y squared and cannot be solved for y. So these sorts of equations are called implicit equations. More generally, any expression f containing x and y which cannot be solved for y is called implicit equation. So here's some examples. Now, you might have taken derivatives of normal, explicit functions before. Now, the question might be raised, how to differentiate implicitly given functions? Now, as a rule of thumb, to take a derivative from implicit equation, differentiate each term with respect to x, normally, like you would do, applying the chain rule to differentiate any function containing y, so by attaching dy dx. Okay, suppose you have to differentiate this implicit function. So this is an implicit function since it contains minus 5y to the fourth term. Now, let's begin. The derivative of 6x squared by a power rule is going to be 6 times 2, x to the first power. Derivative of x is going to be 1, and we are moving to the next term. We are going to differentiate it normally, so by applying a power rule, so bring this 4 as the coefficient in front, keep the constant, and reduce your power by 1. But we are not done yet, since this is term involving y, we have to multiply this term by dy dx. So we have to attach dy dx. It's very important, do not forget. Moving to the next term, derivative of negative 1 is 0. And also keep in mind, actually we have to differentiate the right side also. But since this is 0, it doesn't change. So technically we are done. All we want to do is just clean it up. So it becomes 12x plus 1 minus 20y cubed dy dx equals 0. And the next step, we want to solve it for dy dx. So we want to express, in other words, dy dx in terms of other variables. So use your basic algebra skills to solve for dy dx. And I think the best way, since dy dx appears to be a negative term, so we have negative in front, the best way to solve this just by moving this term to the right side by adding 20y cubed dy dx to both sides of your equation. So in the next line of your work, bring down 12x plus 1 equals, on the right side we'll get 20y cubed dy dx. And finally, the last step, whatever attach your dy dx, you want to divide through again both sides of your equation in order to isolate dy dx, get it alone. And we could actually swap the sides and write it in the normal order. So dy dx equals 12x plus 1 over 20y cubed. So that's gonna be your final derivative.